Hello, my name is Christine Luby, and I'm an education specialist at the Office of Early Childhood. A 2007 study showed that children who do well in literacy and math early on do better in the long run academically. Moreover, math is more predictive of later on academic success than literacy. Let's think about that. Early childhood settings have always focused on alphabet, using language, literacy-rich environments, etc. However, how much time and energy has the early childhood field put towards math? Of course, we talk about numbers, some counting, some shapes, but do we intentionally teach the basics of math in order for children to be successful as they build upon their skills? Because of the importance that early mathematics plays in their growth, we have created a 3-part video series. This series will help teachers and administrators understand their role in the development of early mathematicians. During the videos, the goal is to encourage you to mathematize the world around you, make mathematics more than the manipulatives, help you to understand the importance of early learning, to instill math into children's whole beings, and support children to deepen their understanding. The Nebraska Early Learning Guidelines were created as a framework to guide decisions about planning appropriate activities and experiences for early childhood programs across the state. These guidelines provide information about what children typically should be expected to know and what adults can do to provide experiences to support children's learning. Within the math domain, there are 3 components, including number and operations, geometry and spatial sense, and patterns and measurements. This segment will focus on number and operations. As we dive into the early learning guidelines a little deeper, let's look at the widely held expectations for number and operations. Children ages 3 to 5 should be developing awareness of number and numerals through their use of one-to-one correspondence, distinguishing between numbers and letters, and identifying written numerals. Children should also use language to demonstrate understanding of space and time, and phrases like next to, on top of, before, or after. And children are beginning to learn sequences of events in time like first, next, and last. Another expectation is that children develop an understanding of the counting process, including counting in order up to 10 or higher, counting all types of objects, and playing with counting forward or backward, and children are also judging whether groups of up to 5 objects contain the same number or different numbers of objects. So let's look at what that means in the classroom. Children are comparing quantities of small groups of objects, using words like more or less, or some and all. They are recognizing numerals, pointing to objects as they count. Children are using words like yesterday, today, and tomorrow in conversation. They're counting in nursery rhymes and finger plays. Children are identifying when changes are made to quantities and are using numbers daily by describing their learning experiences and solving problems. Now let's focus on what teachers need to know to be able to help children develop their math understanding in order to grow their understanding of number and operations, or we'll call it the ABCs of 1, 2, 3s. First of all, numbers are used in many ways. Numbers can be used for identification purposes. Let's think about the number 10. When we look at this picture of the boy in a football jersey, it doesn't mean there are 9 other players in front of him that are wearing jerseys 1 through 9. It also doesn't mean that the boy who is wearing number 10 is bigger than any of the jerseys that are lower numerals. Numbers can also be used as a shared reference point, like when looking at the temperature. If it's 120 degrees, we know it's hot. Numbers can also be used to describe quantities, such as these 2 cookies. Numbers can also be used to describe the order, such as first, second, third, fourth place, etc., which can also be confusing, as you want to be at number 1 when we're talking about place order. However, when we're talking about cookies, I at least would want to have 2 cookies instead of 1. So you can see how numbers might cause confusion to some of our youngest learners. Even though numbers are all around them, they can be used in so many different ways. Back to the ABCs. Quantity is one way to describe a set of objects. We can use numbers to name those quantities, and also quantities can be perceived. In order for children to understand number as a quantity, they have to be able to look past other details. For example, 3 white geese and 3 white flowers. They're both 3, so children have to understand that 3 of one thing may look different than 3 of another thing, but it's still 3, even if the sets of objects are vastly different. For example, 3 elephants are the same number as 3 ladybugs. It's also important to think about the use of language. At the same time we're trying to help children understand what 1 means, they're also hearing about a team that won a game. And then there's the idea of using the number 1 as both a noun and an adjective. Adults may not realize that they're sending such mixed signals to children when they're trying to expose them to higher achievement levels. For example, sometimes adults are quick to encourage children to learn through rote memorization number facts, such as 1 + 1 makes 2. However, without the understanding of what 1 is, and how it can mean 1 flower, or 1 goose, or 1 whatever plus another 1 of something to equal 2 somethings, it's much too abstract to be understood for many children. Furthermore, when thinking about language, think about how similar numbers sound the same, especially to some children, like the number 30 and 13. Even while listening to this recording, it may have been difficult to hear the difference between these 2 numerals. Numbers can also be perceived. Children are born with the ability to understand the differences between 1 and 2 objects. Additionally, with practice, they can quickly perceive how many collections of 3 or 4 items. When numbers get a little bigger, such as the number 5, if objects are set in a specific order, like on this domino, it is easier to perceive how many dots there are than if they were arranged in a different way. So as a teacher, it's important to not always provide dots or manipulatives in the same arrangement to help children develop this skill further. While quantities can be perceived, it's important to help children learn that counting can be used to determine quantity if the number of items can't be perceived, and that in order to count effectively, one must learn the rules. While the rhythm and pattern of counting has children engaged from the beginning, think about the correlation between counting to 10 and singing your ABCs. Children from a young age can sing the ABCs, but they do not yet understand what an A is or what it's used for. Saying the numbers 1, 2, 3 has the same result if there aren't concrete experiences to go with the words. When working with numbers, it's important to help children understand why we might be saying the numbers. For example, to figure out how much or how many of something like these candies there are. To add to the confusion of counting for young children, no matter which way these 3 dots are set up, and no matter which dot you start counting on, the total is always 3. With counting, there are rules. This is where rote counting does children well. No matter what you are counting, it always goes in the same order. 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. This is called the stable order principle. In a sense, counting is easier than the ABCs. Many people like to compare the ABCs and 1, 2, 3s, thinking the two share some of the same rules about order. However, think about the number 35 and the letter L. If I asked you what was 4 less than 35, you would find it much easier to solve than if I asked you what letter was 4 before the letter L. So counting is obviously more than just the same order of numbers. Each number is always 1 more than the number before it, and 1 less than the number after it. Rote counting doesn't teach that concept. Furthermore, think about how, when a large group of children are counting larger numbers, many get caught on the numbers that lead into the next decade number. They may understand what comes next when chanting 23, 24, 25. However, at 29, it's difficult to remember what's next in the pattern. We also have to address one-to-one correspondence. There is great difficulty in connecting the physical act of touching objects to the verbal act of saying the numbers in their correct order, and then even more difficulty in announcing the final number as the total number counted. And finally, as mentioned earlier, regardless of which order you count the objects in, such as when looking at the dots at the top, it doesn't matter if you start on the left side, middle, right side, upside, down side, which order you go, it will still equal the same amount in a given set. Let's get back to the ABCs of 1, 2, 3s and look at letter F of the 1, 2, 3s. When we look at this, we can really focus on daily lives. Think about the number of times daily that everyday life brings up situations of how many more are there now, or how many fewer of something there are. Children are sensitive to quantities. They are very quick to know if another child has more of something than they do. Think about at snack time or when playing with toys. This is much easier for children to understand when they're comparing the same things. Think about the example given earlier of 3 elephants and 3 ladybugs. If they were lined up next to each other in real life, it could be very easy to see why a child would think there were more elephants than ladybugs. However, when pictures of the 2 species are lined up next to each other and the same size, it's much easier for children to understand how they are the same number. Matching is an easy way for children to start to see the relationships between numbers of items. They begin to understand that 4 isn't too much more than 3, and that 8 is quite a bit more than the number 2. Comparing these sets of objects are the precursor for addition and subtraction sentences. Finding out how many more or how many fewer of an item is much more abstract. As a reminder, while these are precursors for addition and subtraction, using plus and minus equations is too abstract than most children can handle at this age, and therefore should be used sparingly. Instead, spend more time on the act of recognizing differences among the groups and number sense in general. Children are also learning how whole parts can be made into equal or unequal parts, as well as parts being put together to make a whole. Think about a candy bar. Children understand that you can break the whole candy bar into 2 pieces, and each can get an equal or unequal, depending on who is breaking the candy bar, part. And also that parts can be turned into a whole, as in the case when working with puzzles. However, in order for children to best understand these mathematical principles, more than just experiencing the broken candy bar or putting the puzzle together has to happen. That's where the teacher comes in. Let's go back to the Nebraska Early Learning Guidelines. Not only do they describe what the expectations of children are, it also gives information about expectations for teachers. Teachers should offer counting materials and activities throughout the day, such as number puzzles, books, finger plays, songs, computer software with counting games, and stand timers, not just during free choice time, but also during large groups, small groups, transitions, meals, outdoor time, all the time. They should provide opportunities for children to pair objects, to count both common things like blocks and silly things like freckles on their arms, as well as to develop and practice using number words. Teachers should use descriptive words throughout the day, such as yesterday, tomorrow, before, and after, and give children opportunities to practice grouping objects and comparing quantities. Math should extend beyond the materials and the manipulatives. So how can teachers support learning? First, teachers should start with small quantities of numbers. In fact, numbers that are less than 10. This helps children understand that 3 elephants and 3 ladybugs are still the same quantity. Furthermore, by overemphasizing rote counting to higher numbers, it is actually counterproductive, as children don't yet understand the differences between larger numbers such as 25 and 89. Teachers should introduce numbers with concrete manipulatives, numerals, sound movements, language, and gestures. This means having numerals with corresponding pictures of what the numeral means, as well as modeling and encouraging children to use their fingers as they count. Look at visual number sense. Make sure that you provide different visuals for the same numbers. For example, the number 5 on the domino to help children with their visual number sense. Help children understand the relationship among numbers by talking about numbers using words like fewer than and more than. Teachers should develop counting skills through authentic experiences using concrete examples, rather than counting for the sake of counting. Teachers should be using math throughout the day, including during transition times. Counting can occur to help take attendance, for lunch or snacks, to line up, even to help solve problems like sharing toys. Teachers should also emphasize patterns in numbers and structure. Have you ever wondered why children catch on so easily to counting by 5s or 10s? What is readily available for them to count that is already in sets of 5s or 10s? Their fingers and hands. Think about the use of calendar when it comes to helping children with number patterns and structures. Many teachers think they have to do calendar to help children learn how to count to 30. However, when you look at the calendar each month, number 1 doesn't always start at the top left box. And rather than going by 5s or 10s, it goes by 7 across, making it more difficult to understand the number pattern. I encourage you to think about your use of calendar time as math with these things in mind, and wonder if you might be able to try more effective math practices during calendar time, such as creating a month number line or documentation displays to show what your class did last week. Teachers should also foster children's problem-solving strategies. Allow opportunities for children to discuss and explain their methods, and provide children with words and knowledge as you or they are solving their problems. For example, use self-talk when you're setting out napkins and see that you don't have enough napkins for all the children at the table. A final strategy is to focus on understanding. Just like it's easier to tie my daughter's shoes than wait for her to figure it out, it's not helping her solve the problem. Support children as they solve problems in ways that make sense to them, so that it lays a strong foundation. Children are then able to build on what they have learned to tackle new and more advanced problems. For example, a child who understood that when they were sharing blocks with a friend had to each take one at a time to make sure they both had the same amount, might soon be able to grasp how to share blocks with multiple friends. There are many materials and environmental factors to consider to enhance the mathematizing of your early childhood classroom. Ensure that materials are available within the daily routine for sorting, comparing, and counting, such as small blocks, colored bears, magnetic shapes, large beads and counters, Velcro and magnetic blocks, and pegboards. Provide children with shallow containers for them to use with their materials to keep the pieces together. Offer a variety of places for children to use materials, for example on a table or a vertical or slanted surface. Make sure to have objects that include numbers and number words for children to use. Things like clocks, timers, calendars, thermometers, calculators, measuring cups, number lines, etc. Provide children with games that encourage children to identify numbers and use numbers in problem solving, as well as to ensure there are print numbers with corresponding pictures. We've looked at the Nebraska Early Learning Guidelines, discussed how the environment can assist with the development of math skills, and now let's look to see how to assess those skills. Nebraska Public School Districts use Teaching Strategies Gold. Objective number 20 of Gold 2.0 is all about using number concepts and operations. As you look at the different areas that children are to be assessed on, think about the materials and experiences that we've already talked about and how those play into these assessments. As a reminder, Gold is an observational assessment and should not be treated as a one-time test of skills. Think about the materials that you have in your room and the way math should be incorporated into all parts of the day to assist with the assessment of math skills. If children are counting as they jump across sticks on the playground, how could that be used to assess? If a child is pointing to the numeral 3 on the poster on the wall and then counting how many dots correspond with that numeral, telling you how many, how could that be used to assess? If while waiting for their turn to use the restroom, teachers are asking children to match their fingers to the number of fingers the teacher is holding, how could that be used to assess? When talking about assessment, it's also important to know where the kiddos are going, especially as they move into kindergarten. Here are some of the Nebraska K12 standards dealing with number and operations. It's important to note that by the end of kindergarten, children will be able to demonstrate these skills. Now think about how the experiences you provide in your early childhood classroom before children enter kindergarten will help those children achieve success. One of the best ways to support children's learning is by ensuring that subject areas cross. Here are some examples of children's literature that can be used to help build and develop number and operation skills in your early childhood classrooms. Just like in every other aspect of learning, remember that children learn best through experience. So make the books come alive and allow kids to explore numbers and operations. As adults, we often need resources to support our learning. Here are some additional resources that you can use to help build and develop your skills in supporting children's learning of numbers and operations. Based on this video, Take some time to reflect on the following questions. How can you incorporate number and operations into the transitions or classroom centers such as blocks and dramatic play? How can English language learners show their understanding without articulation? This concludes Part 1 of Early Mathematics with a focus on number and operations. Thank you for your time and dedication to supporting Nebraska's littlest learners. Please join me for Parts 2 and 3 to continue to engage in mathematizing the early childhood classroom through the environment and your interactions with children.